Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallesham, Devasane. In this session, I'm going to talk about I'm going to explain how to construct the push-down automata and how this machine is different from finite automata, and what is the benefit if we are going to construct the push-down automata. What kind of problems we can solve or understand using push-down automata. So if you look at the previous finite automata concept, in the finite automata we can't remember. If you want to remember anything, that is only finite things, that is by using the states you can remember finite things. But if you want to remember arbitrary length, it's impossible using finite automata, right? So in push-down automata we have a stack to push any length, and later on you might compare with some other symbols, right? That is also using in stack order. We will understand slowly what is the push-down automata, how what kind of problems we can solve using PDA, and those problems we have solved using finite automata we can also solve using push-down automata. But push-down automata can also understand some of the non-regular languages. So here that is the difference that we are going to talk about. Now, before starting today's session, let me introduce myself. Myself Mallesham Devasane. I am verified educator on Unacademy. I am working in the field in the goal that is GATE and ESE, and I am going to take the classes for CS and IT. And some of the plus courses I have already taken, like C programming, TOC compiler, and we have many other educators and who are teaching, including my subjects as well as other subjects too. And you will have many benefits if you are going to visit unacademy.com. And also if you want to visit my profile, unacademy.com/DEVALIVE. And to access my free classes, use the referral code DEVALIVE. So if you want to attend any free classes, you require a referral code. So please use DEVALIVE referral code to access any free class on Unacademy. So you can get two benefits. You can access free classes, as well as you can go for plus in future if you require, if you are seriously preparing for GATE exam or any other exam. So you can easily remember the code DEVALIVE. Whenever you need any referral code, you can use this code to get 10% discount, as well as to access the free classes, and in that you can go for plus or iconic subscription if you are needed. Okay, you might ask, what are the benefits are there in plus subscription? You have the live classes from every educator on Unacademy. That's the first benefit you have. And you will have many kinds of courses like long term and short term, and crash courses, revision, so many, and weekly tests, doubt solving sessions, and rank improvement batches, and classes will be there in both separately in English and Hindi, so you can attend any classes. And iconic, all the benefits of plus. Additionally, we'll have a personal coach, study planner, and many other benefits too. And these are my free sessions. You can access them using DEVALIVE referral code. And more than 370 classes. This was 350 classes, but you can see really more than 370 classes on Unacademy, and each one is about 1 hour session. And you will find the quizzes, you will find the classes, you will find the revision batches, revision classes, you will have a practice classes, and so many daily practice problems too, and guidance. All these classes you can access by visiting my profile, and choose the GATE and ESE goal. And while login, you may require the code. Please enter DEVALIVE referral code to log in and choose the goal, and you can go to the search or go to my profile to access the classes. In case if you are looking for the subscription, click on get subscription. You will be redirected to the plus or iconic. You can choose any of them. The plus, you have the best benefits you have already, and iconic, additionally you will have these benefits apart from plus. If you look at the educators on Unacademy, benefits of taking plus or iconic subscription using DEVALIVE referral code, you have a lot of benefits, like you can attend any course from any educator, and you will have a batch wise, and you will have so many benefits. Recently we have also started the batches, and you can attend any batch on Unacademy. So you will have structured courses from all educators, and you will have multiple courses for the same subject, and same subject you have multiple educators, and study as per your interest, and so many benefits by taking the subscription plus or iconic. And we always recommend to go for plus or iconic, but go for always 1 or 1.5 year, 2 years. The reason is you will get benefited to learn all the subjects from many educators, remember that. And do not forget the referral code DEVALIVE. And similarly, you have iconic plans 1 year, 2 year, and choose it. Look at the total price after entering the code. So DEVALIVE, you will see the total price here. And you have so many educators on this channel. You will have access to all of them. Please visit this channel and go to the playlist and access to every class that you want. And please like the session and also share with your friends. Right, if you are watching this video, please do not forget to like the session. Right, so what is the topic we are going to see? That is, in previous session we have seen context-free grammar. In context-free language we have learned the context-free grammar, where the context-free grammar is one of the representation to represent the context-free language, where it is going to generate a context-free language. If anybody asks what is a language generated by context-free grammar, language generated by CFG is context-free language, right? This CFL may be finite or regular or maybe non-regular, but the language generated by context-free grammar is the context-free language. So today in this session there is another representation of the context-free language, that is a push-down automaton. Yeah, look, Ismat. Good evening, Shubhasri. And the people who are studying the theory of computation are going to filter now, because so far the finite automata are going to look very easy, as everything you can understand through the states. But now you are adding one data structure, that is a stack. Any logic that you build using PDA, you need to think about what is happening to stack every transition. So where the people are going to filter, previously you are having only states, so moving on the states is going to be very easy from one state to other state. But if you want to go from one state to other state or same state, you need to look at the same time what is happening on the stack. So here the difficulty, or here the concept starts in theory of computation. So anybody want to learn the theory of computation, actually they should start focusing more on now onwards. Now, the context-free languages, that is context-free language, let's say one language I'm talking about, context-free language you want to represent. And what do you have here is, one is the context-free grammar. Now I'm showing you PDA. And whether you represent CFG or PDA, they are equivalent, because both are going to represent just a context-free language. Like in regular languages, we have every regular language you can write regular expression, you can write finite automata, you can construct finite automata, or you can write a regular grammar. So many things are there to represent the regular language. Yeah, good evening, Nikhil. Now, in this session especially I am talking about PDA, push down automata. So how this is going to be different? The finite automata basically is less powerful than push down automata. It's not about one machine, but I'm talking about any machine in the world which is a finite automata or which is a PDA. If you are going to look at the finite automata, I'm talking about this machine is less powerful. Why? The reason is the languages understood by finite automata, languages accepted by all machines, all finite automata we are talking about, not one, all finite automata is inside, it is a subset. This is called as set of all regulars. It's not a one regular, remember that. Set of all regular sets, because each regular set we have a finite automata, is inside the languages accepted by PDAs, accepted by all PDA we are talking about, not one PDA. And this is called as the set of all context-free languages. If you look at that, every regular, note 1, the first point, I will write three things here. I will write three things. First point, every regular is what? Every regular set is context-free set. And second, this is the true. And second point, if anybody saying regular set is subset of CFL, say it is false. May or may not be. Remember that it depends on what language you are talking about. May or may not be, need not be, only sometimes depends on the language. It's basically, we say the statement is a false. It is a false. Only some subsets are, some regulars are subset of some CFLs, not all of them. 3. But the set of regular sets is subset of set of all CFLs. This is the true again. And anybody using the is and subset word, be careful. The is different from subset. If every regular is a context free, doesn't mean that regular is subset of CFL. Regular need not be subset of CFL. Remember that. Okay, the few points that you require to remember in the beginning of this chapter. The first statement, the second statement, many people does mistake. Regular set need not be subset of CFL. Remember that. Okay, that you will understand slowly. One example to have a clarity here. A star B star is a regular, and you will know that A power n B power n is not regular, but it is CFL. But this is a superset. Remember that. Regular need not be subset of CFL. The relation can change, because we are talking about a particular language. Please don't use the word regular subset of CFL, is wrong. Okay, I'm requesting everyone. Fine. So now what is the difference between this PDA and finite automata? The PDA accepts a context free language and finite automata accepts regular language. Now when you are going to look at the PDA configuration, guys, and PDA, a machine can be represented using Q, sigma, delta and Q naught, and F, that is a Z naught. Some people will represent with bottom symbol, and a gamma. And here two things, that is Z naught is called as bottom of stack, or you can say initially top of the stack. Initially we will place top of stack symbol. Okay, the gamma is called as stack alphabet. Any symbol that you use on the stack is going to present in stack alphabet. Okay, remaining parameters you have already studied. So what is going to be the meaning, that I will explain slowly, guys. Okay, so don't hurry in understanding the configuration. Okay, and here we have head. Assume that we have a finite control, like just like a finite automata. But additionally, what do you have here is a stack. Additionally, you will have a stack. It is unbounded stack, but practically unboundedness you can achieve using pointers, or you can implement the memory using heap memory. Then that you can achieve, but array you can't use in C language. Fine. Okay, now we have the configuration. You can look at in case suppose I have AAA, triple B is my string. Maybe I am going to understand, you don't know that, A power n, B power n. So what I do is, my concept is everybody can decide, everybody can implement the PDA different way, no need to implement the same way. Remember that. And what I do is, initially I keep Z0 on the stack. That is the initial configuration, right? This is the initially we will keep it. Why do you require to keep? Because how do I know that stack is empty? If my top of the stack is Z0, okay, I will know that okay, stack is empty. And this is called as a finite control. What is the finite control? Just like you have the finite configuration, you have few states and few transitions in the machine, and this is read head. This head moves only one direction, remember. Okay, now what I do is, because I want to understand, okay, this is, I will push. How do I push? For each input A, I push X. You can do that. You can do that. And for each B, you can also push A. That's your choice. But I want to implement my way. For each B, for each input B, I will pop X, because X I pushed it, so I need to pop X only. So what I get here, this head is going to keep on moving further. When I look at A, I push X, and when I go to the next A, again I will push X. The head keep on incrementing somehow, and when it sees a B, then it start popping. How? This B will pop this X, each B, and this B will pop this X, and this B will pop this X. And how do you know the stack is empty? When end of the input occurs, maybe you can represent using dollar or any special symbol that you wanted. When end of input occurs, dollar is not compulsory. The stack left with Z0. That stack has Z0 as the top of the stack. Oh, when this happens, you got to accept. This is acceptance. Now, this is how we built using PDA, but right now don't worry. Then what I am trying to explain here, okay, here I may have the Q is the set of states. Everybody knows that Q, maybe you will have Q0, Q1 inside. So you might have the states. So Q represent the set of states. In any problem in the world, any program or any machine, you should have finite number of states. And sigma is input alphabet, which is A comma B, and that's over. And delta is what you design every time. For you and for me, the machine can be different. The delta is a transition function. We will understand slowly, because deterministic machines will have a different configuration, different function, and non-deterministic machines will have a different transition function. And Q0 is initial state. That Q0 is one of the state only in the Q. And F is the set of final states. Okay, in finite automata you always have F, but in PDA it's not compulsory. Without final state also you can understand the language. So we will see slowly. The F is optional. This is not compulsory. Z0 is also optional. Without Z0 also I can understand the problems. And gamma, what is gamma here, guys? Gamma is a stack alphabet. Look at on the stack, I have a Z0, I have X, that's all. The gamma represent what are the symbols that you use on the stack. And gamma can be different from your sigma, remember that. Gamma can be different from your sigma. Sometimes can look like same, but it's not all the time. Fine. Everybody, if you are watching this video, please like this session. This is just a beginning of a PDA. What symbols are there in PDA? How do you understand the configuration? And here we have two machines. Guys, if you want to understand the delta, PDA actually called as non-deterministic PDA. Another name of PDA is non-deterministic PDA. And DPDA is a deterministic PDA. Remember the word PDA also called as non-deterministic. You may call it as PDA, or you may call it as NPDA, or you may call it as NDPDA. But here if you look at the relation, the delta for a deterministic machine, Q sigma cross gamma, you will get Q cross gamma star. Additionally, two parameters are there. Here this represent the top of the stack, who is going to be, this represent operation. To understand operation, what operation you are going to perform, you need to look at the right side. What top of the stack you are going to look at, all the top of the stack symbols are there in the gamma. Gamma is a set of top of the stack symbols, remember. set of the stack symbols, and Q represent present state. When you are writing any transition, present states are belongs to Q, and input symbols are belongs to sigma, and next state also belongs to Q. This is about deterministic PDA, DPDA guys. This is about DPDA. This is about DPDA. And you have NPDA, PDA, we can say that. PDA, what is the delta? PDA, we can have a sigma, you can use epsilon, and gamma, you can use epsilon, and you can use a star. So many choices you have, all are optional. Okay, and here 2 power Q cross gamma star. This is called as non-deterministic. In the non-deterministic motion, the number of transitions from each state not known, maybe 0 or more for a given combination. And this is going to be complicated in understanding the motion, so which takes much time to understand what exactly this domain and codomain of a transition function. This is for PDA, and first one was a DPDA. And DPDA will have a deterministic logic, that is from every state for every input symbol, and when I look at the top of the stack, you will go to one state and you will do one operation. So we'll get to know slowly, and do not worry much about this too. This will come to know very slowly. Okay, fine. And we have a configuration for DPDA, configuration for PDA looks different because of transition function is different. Now, before designing a PDA, you should know there are 2 things guys. PDA acceptance mechanism are actually 3 types. A PDA can be designed, then it can be accepted. PDA can accept a language by using final state. PDA can accept a final language, PDA acceptance by final state, by using final state mechanism. And PDA can also use empty stack mechanism. This is another mechanism guys. Without final state also you can do that. And if you are really interested, you can build using both mechanism. PDA acceptance by using both final state and empty stack. You can also use both of them if you want it. But what is the difference between all the 3 mechanisms? Okay, that you require to understand one by one. Okay, before explaining, let me tell you, in DPDA we have only 2 mechanisms. DPDA acceptance by final state, by using final state. If you use empty stack, that's not going to be DPDA. That's not going to be equivalent to DPDA. Remember that. By using final state. Another one we have, you can use the both if you want, but only empty stack you can't. By using empty stack. You can do that, but it's not equivalent to power. So both final state and empty stack. And there is another mechanism using empty stack only, but that power is not equivalent to this. These 2 are actually called as DPDA only. DPDA you can say by using final state or by using empty stack, all are same here. DPDA equivalent to DPDA by final state, or both DPDA by both, by let's say both final state and empty stack. But if anybody using here only empty stack, that is very dangerous for you, and DPDA by empty stack is going to have less powerful than actual DPDA. So that's not going to be called as actual DPDA. It's less powerful than DPDA. Fine. Why is that? Right now it's very difficult to explain. And previous one, PDA is equivalent to, you can use, it was a previous question directly, final state you can use, or empty stack also you can use, because you can understand the context-free language. Any of these techniques all are equal here. When you look at empty stack is different in both the mechanisms. In deterministic machines, empty stack is not going to help you. Always you need a final state to understand how to accept the given problem in deterministic machine, guys. Okay, so this is the main difference between before understanding anything. So now let's before giving the definition of those five machines, guys, if anybody not aware of the plus, remember that what you are learning on this platform, that is Unacademy platform, is not going to be comparable with any other platform. Remember, first point. And second point, those people who are teaching an Unacademy is well experienced, and we guide you in right direction. We give you right content, and which is everything that we talk according to the syllabus, and we never hurry in explaining the concepts. We never confuse you. That is the main concept. Whatever we teach, that depends on our knowledge and experience, and we look at what is right and wrong. Even we do mistake, we will agree that this should be corrected that way. So we are not here to misguide all the time. We will help you to crack the exam. Remember that. This Unacademy says that let's crack it. Even every educator says that let's crack the exam. So we are always positive in the manner of cracking the exam. Remember that. We are not here to just hurry in completing the concepts, and we always keep on guiding you in the right direction. So if anybody joining on plus, you get the lot of benefits that you are going to learn from the top educators on Unacademy from India. You are talking about and iconic, and all the benefits of plus. Additionally, you will have one-to-one guidance, that is a personal coach will be assigned to you, and you can interact with every educator personally. You will be provided a schedule to interact, and many more you have the benefits. Okay, now before construction of the PDA, now I am not hurry to construct the PDA, guys. Here, first definition, I'm sorry for that construction, I can't explain you. Yeah. Oh. Okay, let me tell you what I was teaching. Am I advertising? Yeah, Shubhendu, you just came first time. I was teaching from last almost 20 minutes, and you just came now and you wanted to start the class, right? And we don't care those people, guys, and we are teaching, Shubhendu, and you are not eligible to attend our classes because you are not knowing what we are teaching. You're already late to the class. Okay, first concept. You don't understand even what I teach now. PDA, acceptance by final state. Before talking in front of educator, please have a respect. By final state mechanism. And we are always there to help you. But why can't we promote? Obviously, when we teach freely, right? You must listen to us. Alright. PDA, acceptance by final state. What is the definition of PDA that I am talking about, guys? Before this, let me help you. What is PDA first? Then you will understand what is PDA by final state. What is PDA? And if you give a string, if we give a string to a PDA, what it does basically, and very less people know about what PDA does basically. If W belongs to L, it must say accept. If W not PDA, let's say accepting some language, that is CFL. If W not in L, then it must say reject. But how it says, that depends on the nature of the PDA. Whether I use the final state or empty stack, that will talk about what kind of PDA it is, how it accepts, how it rejects. That depends on the type of the mechanism, how it accepts or rejects. That depends on final state or empty stack mechanism, or both. How do we say that acceptance and reject? Are you clear? This is a standard definition of what is PDA. Everybody, what is PDA? If the string belongs to language, then you must say accept. How? Don't say now. First look at your machine. Are you designing using final state? Definition changes. How that changes? Let's see. Right. So I'm assuming this PDA accepts L using final state mechanism, because it is I am designing, I know it. Well, how do I design? It's my decision. I can design final state, I can design empty stack, I can design using both. So now I'm just taking as an input string, that is the W. You give the machine, I know how do I design, because I can understand how to run this machine. If W belongs to L, what happens? If W belongs to L, we don't know what is that. Basically we are assuming it. W maybe belongs to, W may not be belongs to. And if belongs to L, the machine should halt at first PDA by default non-deterministic machine. Remember that point too. PDA by default non-deterministic. I can't say exactly one path. So we have at least one path exist in the machine, no doubt, because it is a valid string. I must have at least one path, and among them that one path should halt at final state. This is how we design. If W not belongs to L, I no need to show anything. I know that there is no path halts at final. That's enough. There is no path halts at final. Either I may not have a path, even I have a path, I will not halt at final. There is no path halts at final. Either I may have a path that halts at non-final, or I don't have a path. It's fine, because that is a non-deterministic machine, guys. Clear this point? This is the definition of PDA if constructed using final state mechanism. Now there is no empty stack concept, because my nature, the PDA nature is the final state mechanism. Now I am going to build the another one, PDA acceptance by empty stack. Today we will look at mainly definitions. Remember that PDA acceptance by empty stack only I am talking about. I don't use a final state. I have no parameter F now. I don't have the final states in my machine. By only empty stack. Then how do I design? I'm giving input is W, let's say, and this PDA accepts context-free language only, accepts L using empty stack mechanism. And somebody designed or we designed it, doesn't matter. How do we understand if W belongs to L? And again, at least one path exists. Remember that, do not forget that. At least one path, you need to find out that which path, and at least one path exists that makes stack empty, that makes empty stack. Whenever the stack is empty using any path, after reading the string, never forget, remember all these definitions after reading the string. After reading the string only we should decide, not in between. After reading entire string only we should decide whether it belongs to or not belongs to. Without reading the string you can't decide the string whether it is accepted or not. So I will only look at what happens at the end of the input, not in the middle of the input. Remember that. Okay, next one, not belongs to L. and I don't have even single path that can make empty stack. There is no path. There is no path to make empty stack. Then only I will decide that string is invalid. Right? Because it's a non-deterministic motion. Which path makes empty stack? Then you must understand. Nobody will tell you this path goes to. You have to find out. Non-deterministic machines are very difficult to understand. Maybe they are easy to design. Clear this point so far? Come on guys. PDA acceptance by empty stack. Next one. Sorry, again. Third one. PDA. I can design using both mechanisms if I wanted. Acceptance by both mechanisms, both final state, using final state and empty stack. In this case, I'm assuming input is W, some string you can give, and I am assuming this PDA accepts any language L, any context-free language L, using both mechanisms clearly mentioned, both final state and empty stack. This will be given by default in the exam. Which is the mechanism going to be used? If they don't mention, if you have not understood, this is the default mechanism. Remember that. They use the final state by default. But when they want to use empty stack, you will understand there is no final state. When they want to use both of them, they clearly mention the mechanism using both final state and empty stack. Then what happens in that case? Whenever the string belongs to L, because this motion is also non-deterministic. Because deterministic motion has a different definition. Okay, W belongs to L, at least one path exists, and guys, here, don't show me that goes to final, show me that offset final and also stack is empty. Both happens, then only I believe this string is valid. Both of them should happen, not one of them. And at least one path exists that makes empty stack, or stack as empty, and all set final. Both should happen now. If one thing is happening, I don't care. All set final state. You are halting at final state but stack is not empty, then this mechanism is not going to do accept such strings. This mechanism is different from the previous one, but both are equivalent. Whatever you can do here, you can also do in the previous motions too. And if W not in L, and that's not going to happen. You can't show that there is no path that can make empty stack and it can halt at final both simultaneously. There is no path. There is no path exist that can make empty stack and all set final and alt at final. That's not going to happen. Clear this point? This is the definition of both mechanism using final state and empty stack. And when you look at all of them and anybody says language accepted by a PDA by final state is dash, language accepted by a PDA is dash, and language accepted by PDA by empty stack mechanism is dash, and language accepted by PDA by final state and empty stack both is dash, and language generated by context free grammar is dash. All of them are same context free language. But there is one small change in the definition where be carefully look at what I am talking about. This is about single language, right? L, and same I am just using L. Yes, that people say that all languages accepted, it's a set of languages, remember that, set of languages accepted by push down automata. Here plural, many machines we are talking about, not a one machine. Plural word. Previously it was singular word. Language accepted by a single PDA. This time set of all languages accepted by PDA is dash. And now this is can be written as simply LS of PDA is dash. Previously L I have represented, now LS. Now LS means languages, remember, set of languages. This is my notation, guys. And PDA by final state is dash. And LS, remember LS to represent set of languages. This set of languages I am using LS, not a single language, remember. PDA by, what is it, empty stack. Yeah, good evening Karthik. PDA by final state and empty stack. And this was a GATE question. Do you believe that this is the question happened in the exam? Yes, you should believe, because these things are also not clear for undergraduate students. Most of the people, they struggle to understand the English words because they can't understand what is a language accepted by PDA. That is a different. This is language accepted by PDA. Language accepted by PDA is different, is a CFL. And this one, set of languages accepted by PDA, is called as set of all CFLs, not a single CFL. These all are set of all CFLs. Set of all CFLs. The answer is different, guys. Set of all CFLs. Even all the languages generated by the context-free grammars you take is CFGs I am talking about, is a set of all CFLs. This is the most important word when you are studying this chapter. You need to understand what is a single CFL definition, what is a set of all CFLs. Now look at what I am talking about. This box name is set of all CFLs. And this is a dot, this is a single CFL. This is another CFL. And each CFL you have a PDA. PDA exists. And for this one, PDA exists. Not only PDA, CFG exists. Right? Here also CFG exists. Right? So when we are going to talk about set of all CFLs, we say set of all languages accepted by PDAs. All we are talking about, not one PDA. Accepted by PDA. It's a plural word now. This is same as set of all languages, means context-free language, all of them will come inside. Generated by all grammars now. Generated by plural, CFG, yes I am writing. In the previous one, PDA, in a automata is a plural word. Clear this point? And here, this CFL is different. This CFL is language accepted by PDA. Now we can't say set of languages accepted by PDA. What you can say? Language generated by CFG. Look at the difference between this box is also a set and dot is also a set. Both sets are different. In the one set, context-free languages are there. In other set, the strings are there. CFG is a context-free grammar. Karthik, context-free grammar. Previous session. CFG is two types. You can use, यार मैं क्या बोलूं अभी, normal form तो बताया नहीं अब तक. You have Chomsky normal form and Grebac normal form. GNF you have, and also CNF. That is different. You can represent in any form. पहले CFG तो पता करो यार, कुछ भी हो सकता है दुनिया में. Alright. मैं CFG बात कर रहा हूँ, वो GNF होगा, CNF होगा, God knows that. Alright. Clear? I'm just talking about CFG. You can take any CFG in the world. That doesn't matter. Clear? Are those you are not able to understand this line? Stop here. Please don't continue this chapter anymore. First understand these words. Okay, fine. Now I'm going to talk about push down automata, deterministic. And guys, DPDA definition. What is DPDA? आज यही करेंगे, लैंग्वेज डिजाइन नहीं करेंगे हम, लैंग्वेज तो आज डिजाइन नहीं करेंगे. व्हाट इज DPDA? ये बहुत लोग को यही नहीं आता, तो पहले इसी को कर लेते काम. व्हाट इज DPDA? एंड यू हैव टू शो समथिंग. ये डिटरमिनिस्टिक मशीन है गाइस. नाउ W, that is input. I'm assuming this DPDA accepts some language L. Deterministic CFL we call it as. Accepts L. Suppose W belongs to L, W not belongs to L. How do you show that that string is valid or invalid? Clear? If the string is valid, now guys, this is the DPDA. At any cost, you have to show with the final state. Empty stack is there or not, that I don't care. String. Exactly one path exists, that hard set final. Stack empty होगा नहीं होगा, you decide it. That you decide it, but definitely I should halt at final. If it is not belongs to L, you can do two things. You can say exactly one path exists, that halt set non-final. That halt set non-final. But this can be designed other way too. For simplicity. For simplicity, this can be designed some other way. You can also do other way, that is, when W not in L, either you can show zero path, 0 or 1 path, enough. 0 also can be converted to 1 by assuming that goes to dead. 0 or 1 path exists. That all set final, that all set non-final, because both are same guys. When you say 0, this is a simplicity. You can implement other way. 0 means it is also exactly one path only, but one path goes to dead state. That is assumption, remember that. When you don't have a path in the machine, you can say that that goes to dead state. It's a deterministic push down automata, remember that. They are going to be complicated for many people because of the only reason they don't understand the definition of DPDA and definition of PDA. Then when they come to identifying CFL, DCFL, they don't understand what they are talking about. They will not have a clarity because they don't have a clarity in the machines. Anybody not able to identify CFL, DCFL, only one problem you have, you didn't understand what is DPDA and what is PDA. That's only the one that you can focus on. And DPDA always focuses on the definition is, how did you get this definition? Because you need to follow this definition. And how did you get the previous PDA definitions? Because PDA is going to be Q cross sigma epsilon. Many other definitions also there, guys. Many other, I'm not talking about other definitions. Remember, this is actual definition. What I am speaking in theoretically, all these definitions are just defined by delta only. Okay, that you get slowly. Now you got the DPDA definition, but this can be implemented using final state or both. Using final state and using final state and empty stack. If you want to use the final state, definition is over because this is a standard one. If you want to use also empty stack, then say that exactly one path exists that halts at final and also makes empty stack. That's all. Just add one more word, belongs to L, makes empty stack. Clear that point? Answer is here itself. Just add empty stack, do you want it or not, when the string is valid, guys. Okay, I'm not going for that, remember. Okay, clear this point? Everybody? Okay, but differences I will slowly talk about. Okay, now we will focus on construction of PDA, guys. Construction of PDA. I don't think I will explain today, but this is the beginning for the next session. Next session, whenever I take on Monday, on next after 2 days, because Saturday, Sunday we run other sessions, right? Yeah. Yes, Shubhasri, that is what I am talking about. You can, but in that time the string is valid. Shubhasri, it's just a beginning. Shubhasri, yes, you can have a two paths. One goes to final, other goes to non-final. But do you have a path that goes to final? That means it is a valid string. It is a valid string. Even though I have a path that goes to non-final, I don't care. You must focus on. Remember, if you are looking at non-deterministic motion, your focus is different. Non-deterministic, any motion, finite automata, PDA, Turing motion, non-deterministic motions. Non-deterministic motions. Remember that? What do you look at? Focus on can I reach final. Don't focus on can I reach non-final. Focus on can I halt at final. Focus on can I make empty stack. Focus on can I make empty stack. Don't focus on other paths. Focus on can I make both, can I halt at final and empty stack. This is how PDA we think about. This is the first mechanism by final state. This is by empty stack. This is by both. Right? We have three kinds of mechanisms. You know that all the three are equivalent. So all non-deterministic motions, can I reach final? That is only your target. That is only your target. If your target changes, if you are looking at can I go non-final, you may go it. But that doesn't mean that invalid string. Valid string can also halt at non-final, remember that. But at least one path exists that can halt at final or that can make empty stack. So here is the difference. Here is the difference. Okay. Slowly we'll come to that point. Slowly we'll come to that point. Okay. Now construction of PDA, guys. And anybody want to understand these motions? You can only understand after designing so many problems. You can look back what was happened. But in the beginning, do not try to understand how PDA accepts the strings. It will waste your time. So even though I explained the first problem for half an hour, but you need to focus on what I am trying to explain. Right? Don't get me bored because of the theoretical concepts behind the pushdown automata. Fine. My famous problem in this is a power n, b power n, where n greater than or equal to 1. First, how do you design the machine? You need to make assumptions. You need to make assumptions, guys. Right? How to represent end of the string? Do you want to represent using epsilon, or do you want to represent using dollar? Do you want to represent using hash? You decide it. So anyhow, you can design the PDA by all assumptions. Fine. First, you decide. You decide first. Decide how to construct. Q, because I can decide. Look at how many problems are there. First, you can use final state mechanism, or you can use empty stack. All the machines are different. Or you can use the both. First, you decide which one you want to design. Then only we can proceed. So I am going to follow all the times this one, but later on I will explain this one. Later we will see this too. Later we will also discuss this. Right? So my focus is on how to design a PDA using final state. Exactly. Is it clear? Without final state also we can design. At that time our strategy is going to change. At that time our strategy is going to change. But अभी तो आपको assume करना ही पड़ेगा how to design using final state. Right? Assume करना ही पड़ेगा. Right? That is the one assumption. Everybody? And what is there? Okay. And still second assumption. I want to design the same problem. It's not another problem, guys. L is equal to a power n, b power n. Now second assumption. Second, which transitions you want to use? This is the first concept, guys. First concept. Concept only, not a problem. Remember, same problem. First concept, second concept. Concept. How do you want to design? Because this can be designed using DPDA. It's also possible using PDA. Also possible in future using Turing machine also. First you decide how do you want to design, because all of them are exist. Is that clear? Romit Soni, please attend tomorrow. Saturday we have the special sessions. You can ask your doubts. I'll be discussing. Do not disturb the class, guys, please. Otherwise I will not look at your chart. And using DPDA or using PDA, because both are exist. If I use a DPDA and I may design a different way, if I use a PDA I may have different ways. So that is the reason I am talking about. You need to decide. You need to decide. And the third concept. For the same problem, do you want to assume any end concept? Okay, you can assume if you want to use a special symbol, do you want to use dollar as end of terminal or not, end of input or not, or epsilon, is your choice. This is another assumption. Is it clear? This is third concept, because at the end of the string you must halt, right? So dollar you can look at, or you can look at epsilon to look at Z naught on the top of the stack if you want it. And this is the third concept you require. Remember guys, third concept. And total 3 concepts you require to follow. First, do you want to use the final state or empty stack or both? Because PDA we have 3 mechanisms, DPDA we have 2 mechanisms, right? So the second concept decides the first concept, which mechanism you want to decide. First follow one of them. I am going to follow final state for all of them, for PDA and DPDA, because that is the standard mechanism in the world. And the next one I am going to use the dollar as an end of the input, because that looks easy. This looks easy to explain. So whenever I get a dollar, I must halt now. Tell me how to halt, how to accept. Are you clear this point? Now this is my concept, and let me explain how do I answer it. And fourth concept is there. Look at that. Fourth concept also there. What is it? If you have the problem and why people can't understand this machine, because logics are many. Logic 1 exists in the world and logic 2 exists in the world. Even you fix all of them before, and infinite logics are there to understand the same problem. Infinite logics are there. Infinite ways you can design this PDA, DPDA or PDA to understand. Infinite logics exist. Example, look at that. Every A, I'm writing the logic guys. Every A, push A. Every B, I pop A. This is how you design one logic. Another logic, why do you want to do this? That one, every A, here a different logic guys. Every A, I can push 2x, I push double x. So after doing for every A and every B comes, then every B I pop 2x. It's my choice. It's my choice how do I design. And logic 3, I can do some other thing also. And like that you may have many logics in the world to understand the same problem. So if you want to look at that, let's see example. Clear? First you need to fix which way you want to design. In the exam you are not going to design, they will give you a machine. You need to understand, that will become easy because they already designed it for you. But if you want to design, infinite PDAs are exist to understand the same context-free language. So here the conflict occurs to the students, which way I should design. The textbook 1 follows a different concept and it looks different way than textbook 2. But first, have you understood what is the PDA, how to design the PDA? So when you understand, you will not confuse whatever the textbook you follow. Clear this point, everybody? Yes. Please, if you are watching this video guys, please like this session, and I believe now I'm not going to explain any fifth concept, but let me tell you the same problem I have. How do we proceed? Basically You take the enough length string, always this is how we proceed. And I'm assuming the dollar is end of the input. You don't need to assume, you can assume epsilon also. But your head starts here and somehow it must reach here. Then you say accept. Accept maybe by halting at final, maybe by making empty stack, but maybe by making both. That you decide how to do that. Are you clear? When you see the dollar, you must say I have to accept. Then how do you do that? How do you do that? That is how we are going to do. First technique that I told, okay, I push all the symbols as it is. How? Every A I push 1A. So initially you may have on the stack Z0. So your head keep on moving further. How long you push? 5 A's there, so we push 5 A's. And when B comes, okay, we stop pushing A's. So this B, we are going to pop A. Indirectly, this A is compared, and this B is indirectly comparing this A. Means this A is popped. This B is compared, this A popped indirectly, and this B is going to be this A. And this B, okay, let me delete this one. This is interrupting. Okay, this is our language where n greater than or equal 1, let's say, and this B is popping this A indirectly. So when you look at this dollar, you can see that when you look at this dollar, who is there on the bottom of the stack? Z0. So dollar comes as an input. If I have the top of the stack is Z0, then we say we are going to final. Accept and halt at final now. Everybody, this all configurations you must decide first. How do you want to push A or how do you want pop A? When you are pushing A, you can't expect pop B because A is only there on the stack, remember that. And this is all we have a problem in the beginning of construction. We push A, but you don't know, are you popping A or B? You have to connect properly. How to connect, guys? Look at how to connect, guys. A power n, B power n is there. On this stack, only A power n is there. So this A power n we will push, and this B power n we will pop this one. Remember that. We will push for this A's and we will pop the same A's. So that connection is important. When dollar comes, the top of the stack must be looking at Z0 only. Are you clear? So this is the acceptance condition because every problem will have a different acceptance conditions. And here dollar comma Z0 is for other problems, dollar comma A, other problems dollar comma B, but dollar decides your problem. This is end of input. Only here you can say how to accept. In between you can't say go to final, that's you can't say. Even you go to final, you must read every symbol till you reach dollar, and you must reach at any cost end of the input. Remember, after reading entire string only, you must decide your answer. To avoid the confusion, we are using the dollar. How do you know after reading entire string? When dollar comes, tell me what to do. Yes, we have only one stack only. If you have the two stacks, the power is going to increase and it can behave like a Turing machine. Remember that. Right? Now n greater than or equal 0, n greater than or equal 1. अरे डिजाइन तो नहीं हुआ ना यार, डिजाइन तो नहीं हुआ. अभी क्या जरूरत है राहुल? मैं डिजाइन ही नहीं किया. आप n greater than or equal 0 है, 1 है, क्या प्रॉब्लम है आपको? राइट? डिजाइन ही नहीं किया यार. मैं क्या बोलूं इनको? मैं सिर्फ इसी के लिए लॉजिक बता रहा हूं. You have to take care of AB, AA, A square, B square and so on. If it is L is equal, एप्सिलॉन भी आएगा एक्स्ट्रा, उसको भी केयर करना पड़ेगा आपको. इफ यू गेट एप्सिलॉन तो इसको भी केयर करना पड़ेगा. पहले आपको डिजाइन करना आया तो सेकंड वाला बहुत इजी होंगे, है ना. आपको इनिशियल स्टेट सेकंड स्टेट तो कंस्ट्रक्ट नहीं किया ना अब तक, तो टाइम लगेगा आपको ये समझने के लिए. ऑलराइट, तो एक बार डिजाइन कर लेते हैं. आज फिर कल से स्टार्ट होगा यही से a power n b power n greater than or equal 1. क्या क्या डिसाइड किया पहले बताओ. ये a से स्टार्ट होगा कल. आई एम अज्यूमिंग फाइनल स्टेट mechanism DPDA or PDA. I am using DPDA. PDA I will tell you after some time, not now. And I am using dollar as end of an input. And Z0 I kept it already. Z0 is initially top of the stack. Sometimes Z0 is not there. You need to push, guys. If the initial stack is empty, you must push Z0. Remember, is the bottom of the stack symbol. Now these all are assumptions. These are assumptions before designing. Now you need to start. Okay, take the bigger length string, then we will proceed what to do. This is our end of the input. Now initially, who is there on the stack? That is our assumption, Z0. And you are in Q0, initial state. And input is A, and top of the stack is Z0. This is the top. This is the input. And tell me what to do. A comma Z0. I have to push. So you can keep the self loop only, because I push by staying at Q0 only. A comma Z0. I'm going to push A Z0. Means this is nothing but push A. By reading A, you are reading A. This is input. And this is the top of the stack. By looking at input A, by looking at the top of the stack Z0, you are going to push A onto the stack. That means Z0 is there, above Z0 A came. Everybody? So this is called as push A. But guys, when you do that, and the pointer will go to the next one, because Q0, now Q0, now A comma A, there is no transition. अगर ऐसे छोड़ दिया ना, the string will not accept, guys. बात ही नहीं है अभी, तो उसके लिए भी एक ट्रांजिशन लेना ही पड़ेगा. A comma A double A. Input is A and top of the stack is A. अभी top ये है. Clear this point? Now you need to say that I will push again. This is also push A. How do you know push A? Because already A is there. One A you kept it. Double A means that extra A came onto the stack. There is push A. Now another A comes, and this is the theory. Top automatically goes, and this is the top now. And now Q0 is pointing to this one. Now the second transition is going to repeat as many times you want it. Now this can push all the A's onto the stack. Now 4 A's it automatically pushes onto the stack. And after some time what will happen? The Q0 is pointing at B and top of the stack is A. Now Q0, if you see B as an input, A as the top of the stack, now no more push. Because we remembered all the A's, we pushed all the A's. Now we need to start pop. How do you do that? Every B pop 1A, guys. Every B pop 1A. That is B comma A slash epsilon. Epsilon says pop. But which symbol? Whatever you are looking at, this is a pop. Everybody, pop A. So now this B is going to pop 1A. This B is going to pop 1A. And you are changing the state. Do not forget here. If you stay here, there is a chance if one more A comes after B, A might push. But we don't have A after B. That is the reason we change the state. That's all. Q1. Now Q1, ये same job है. Every B pop 1A. Every B pop 1A. That is the meaning. Every B pop 1A. Every B pop 1A. है ना? So A. So this can happen by staying at Q1 only. But how do you do that? Q1, when you see the dollar and Z0, look at that. Q1 dollar comma Z0. Dollar if you don't want to use, and you can keep the Z0 or you can put epsilon, that is your choice. Go to final state. Everybody, if you don't want to see the dollar, you can put epsilon there, because end of the input occurred now. And this is how we design. but it's not over, it's just a beginning, guys. And in the next session I'm going to start from here, how to design a DPDA, how to design, why we call this DPDA, and how can I understand this machine accepts only a power n b power n. And कोई पूछ रहा था सर अगर जीरो है यहाँ पर तो क्या करूं, क्यू नॉट से फाइनल पे चले जाना, डॉलर कामा जेड नॉट आया, डॉलर कामा जेड नॉट आया तो डायरेक्टली गो टू फाइनल, क्यू देयर इज नो ए कामा बी, व्हेन यू सी द डॉलर द टॉप ऑफ द स्टैक मस्ट बी जेड नॉट. तो जीरो के लिए बाद में कर सकते आप, उसको टेंशन नहीं है, दैट यू कैन टेक केयर लेटर, है ना. तो फोकस ऑन फर्स्ट व्हाट इज योर लॉजिक. स्पेशल स्ट्रिंग्स आया बाद में कर सकते आप. एवरीबॉडी please like this session, guys, and tomorrow we'll begin how to construct the PDA. And today we have understood the theory behind how to construct, but ये तो start ही नहीं किया construction, है ना. तो in the next class we will focus on for a given problem how to do that. For given language we will do in the next class using this language, right? So today we have seen the theoretical concepts of PDA, and there are so many theoretical concepts, and there is always a difference between the YouTube class and the plus and free classes, guys. And maybe you do not know what things I'm ignoring it, but definitely there is a difference. And actually theoretical concepts for me it takes 2 hours to explain, but I have explained within 1 hour. It means 1 hour content I am missing here, but still that content is also here. I am not pointing out, but it is there. Fine. And if you want to follow me, if you want to learn more from me, please follow these classes, follow my free classes on unacademy.com/devagatecse. If you wanted to access my free classes, don't forget DEVALIVE. Yeah, one doubt, guys. I told you an example. Please, are you sleeping, Nikhil Jain? I have already given. This is A star, B star is a regular example तो दिया ना. और A power n, B power n ये CFL बोलते हैं हम. ये तो सुपर सेट है, तो सबसेट कैसे बोलोगे इसको? नहीं बोल सकते ना. वेरी सिंपल बात है. You cannot say regular is subset of CFL. इसको देख के ही बोल सकते हैं ना. रेगुलर सेट इज CF सबसेट ऑफ CFL. गलत है ना. अरे यार इसको देखो यार, मैं क्या बोलूं इनको. यही तो एग्जांपल दिया ना. ये रेगुलर तो सुपर सेट ऑफ CFL है, तो आप ये काउंटर एग्जांपल आपके लिए है ना निखिल जैन. रेगुलर कैन बी सुपर सेट ऑफ CFL, रेगुलर कैन बी सबसेट ऑफ CFL. द लैंग्वेज विल डिसाइड. क्लियर दिस पॉइंट. रेगुलर नोट, रेगुलर set can be subset of CFL, regular can be superset. ये तो वन लैंग्वेज के है ना, कुछ भी हो सकता दुनिया में. Can be superset of CFL and regular set may not have a relation with CFL. Regular set may not have a relation with a particular CFL, sometimes with particular CFL. एग्जाम्पल ऐसे दे रहा है. सपोज एक ए रेगुलर लैंग्वेज है, रेगुलर है. अनदर वन इज बी पावर डबल बी एंड लेट्स से ट्रिपल बी एंड ए पावर एन बी पावर एन. कुछ रिलेशन नहीं है दोनों में, नो रिलेशन. ये रेगुलर है, ये CFL है, इस दोनों में रिलेशन ही नहीं है, रिलेशन नॉट एग्जिस्ट. तो क्यों? आप ही बोलो. इरेगुलर अंदर नहीं आएगा, सबसेट नहीं आएगा, इज भी नहीं. इरेगुलर को CFL बोल सकते हैं, बट लेकिन दिस इज आल्सो CFL. रिमेंबर दिस इज अ CFL but no relation with that language. Two languages will not have a relation. Sometimes may have a relation between them, but every regular you can say this is a CFL, that's all. You can say this is a CFL, but you can't relate with other language. Other language may have a subset or superset. All right, fine guys, we will look at so many things in future, and please join this Telegram channel. Please subscribe here and you will get daily updates from us, and do not forget to share our free YouTube channels from Unacademy, and top educators are teaching on these channels. and very helpful. And do not forget, DEVALIVE is my referral code in case you want to access my free classes, and this is going to be helpful to access my free classes, to sign in, to get a login or sign in. If you want to sign in on Unacademy, you can use this DEVALIVE, and you wanted to take the subscription, and all of them, this is going to help you, plus or iconic. It is your choice how do you want to use, but we are always there to help you. Please like this session and please share and also subscribe. Thanks so much for today's session, joining today's session, and we will meet on Monday, and next class is going to be on Monday, guys. Tomorrow, day after tomorrow, we'll see the marathon sessions. Yeah. Yes, Nikhil, Devasane is also my referral code. That's fine. I have many codes too. Thank you so much.